In 1926, the German Nazi Party acquired a new piece of coding equipment known as the Enigma. By far the most advanced technology of its time, Enigma was considered completely unbreakable.
The Enigma was incredibly complex yet incredibly simple. It was developed by German engineer Arthur Scherbius. Originally manufactured for commercial use, the German Navy adopted the technology in 1926 and the Army in 1927. The machine was originally broken by the Polish, but they were discovered by the Nazis, and the machine was developed and improved.
It worked by adjusting a set of rotors to a specific group of settings that were changed daily. The machine included a plug board in which wires connected letters on the keyboard to plugs that could be connected to different letters. The message was then typed on a keyboard.
Electrical signals were sent from the key that was typed through the plug board, which changed the signal into a different letter. The signal was sent through the rotors to further scramble the message. It was reversed back through the entire process until a new encrypted letter was illuminated on the lamp board.
The receiver only had to set the rotors to the correct settings and type the encrypted message in, and the original message was illuminated on the lamp board. This is by far the most sophisticated technology of the age and was considered absolutely unbreakable.
The British acquired the already broken Enigma machine from the Polish, but needed some of the parts used in the current updated one. In 1941, the British captured a German U-boat that contained a current intact Enigma machine. They assembled a team of mathematicians, cryptanalysts, and even chess champions at the Government Code and Cipher School, otherwise known as Bletchley Park, to break the new machine.
Bletchley was made of several departments, or huts. Experts worked on all manners of encryption and coding. The Enigma was worked on in Hut 8.
One of the most important members of the Enigma team was mathematician Alan Turing. Turing was born in Paddington, London in 1912. He was sent to Sherborne boarding school when he was 13. He studied many advanced ideas on his own due to the school's discouragement of his scientific interests.
At age 22, he attended King's College in Cambridge, where he wrote a paper on what he called a universal machine, which most historians recognize today as the foundation for the modern computer. He joined the Enigma team in 1939, where he had a rough start with the rest of the Bletchley Park team due to his social awkwardness. He eventually got on with the rest of the code breakers and proved to be one of the most valuable assets in breaking Enigma.
The other members of the code-breaking team included Joan Clark, the only woman to work at Hut 8. She got on with Turing the best, and they were eventually engaged for a short period until he revealed his homosexual tendencies.
The next member was John Cairncross, a Cambridge graduate recruited to Bletchley because of his German fluency. He worked in Hut 8 for the duration of the war, but was later revealed to be a Soviet spy who passed information from inside Bletchley to the USSR.
Hugh Alexander was a British chess champion and mathematician. He worked very closely with Turing in the running and management of Hut 8.
Stuart Menzies was the director of MI6 at the time. He acted as a liaison between Bletchley and Winston Churchill.
Peter Hilton was the youngest member at Bletchley, recruited at only 18. He attended the University of Oxford and was sought out for his incredible intelligence, having taught himself German in only a year. His incredible visualization enabled him to find meaning in seemingly random sequences of letters.
Gordon Welchman worked with Turing to develop the bomb, the machine that eventually cracked Enigma, and is largely considered the foundation for the modern computer.
Finally, Jack Good also worked closely alongside Turing. He discovered that dummy letters used in encrypted messages weren't random. This was one of the most important realizations that led to the breaking of Enigma.
The Enigma had the ability to encode messages without repeating a letter, which made it impossible to break using ordinary ways. Each month, the key sheets were sent out to every German officer, which told them how to set up their Enigma machine for that day. Without these key sheets, you would have to search through billions of keys to translate the messages.
Every message sent used dummy letters to deter codebreakers. The Bletchley team made their first important breakthrough when they discovered that these dummy letters were always the same. Every message included the phrase, Heil Hitler.
These helped to provide the codebreakers with a clue, or crib, which gave them hints to how Enigma was set up for the day. However, these cribs were not enough, and searching through the billions of possibilities was impossible. In order to break the machine, they needed a mechanical way of processing information faster.
The Polish had already developed a machine to crack the Army and Air Force Enigma, but the Navy had a more complicated method of encoding. This left the codebreakers at Bletchley Park, led by Turing, to decode the Navy's Enigma with their machine called the bomb.
On July 9, 1941, the Enigma machine for the German Navy was broken with the help of the British bomb. The bomb weighed about 1 ton and was placed inside a bronze-colored metal cabinet which was about 7 feet wide, 6 feet 6 inches tall, and 2 feet deep. Alan Turing came up with the idea that a machine could sort through all the possibilities quicker and crack the code. How it works is that the bomb searches through millions of possibilities and will stop when the correct encryption is reached. It may sound simple, but the science and engineering behind it is very complex and is considered the beginning and foundation for the modern computer technology today. In order to keep the broken Enigma a secret, Bletchley was operated under complete secrecy.
Here in Bletchley, we had 5 bombs, and there were 2 people to each bomb, so there were 10 of us on a watch. And apart from them, you did not talk to anybody about your job. The minute you walked out of the bomb room, got in a vehicle to go back to wherever you lived, you didn't think or talk about it at all.
After Enigma was broken, the Bletchley team's next responsibility was to relay the deciphered messages to the military. In order to keep the fact that they had broken Enigma a secret from the Nazis, they could not prevent every attack they had knowledge of. When they did act, it was said that the information came from a well-placed spy in Berlin. The codebreakers had to decide which attacks were to be prevented and which ones they had to let happen. Oftentimes, the lives of thousands of British citizens were placed in the hands of a tiny group of mathematicians in a hut in England.
Many would criticize the withholding of information, saying that they caused many to lose their lives and that a few mathematicians were not qualified to make those decisions. However, if they had acted on all the messages they received, the Germans would have discovered that Enigma had been broken and adjusted their methods of encryption.
The war wasn't won by the codebreakers. The war was won by boots on the ground. Without it, the war would not have been lost. But on the other hand, with it, it was certainly shortened by a significant amount.
The breaking of Enigma was one of the most important contributions the Allies made to the war effort. It is estimated it shortened the war by 2 years and saved millions of lives in the process.
After the war, Turing continued to look into ways of deciphering messages mechanically when he came up with the idea of controlling a machine's operation using coded instructions stored in the computer's memory. Turing's connection between electronics and stored programs on computers led to the race to make a stored program electronic computer. In June 1984, a group led by Max Newman built the first prototype and ran its first program. This started a new era with computer technologies. Today, with all of our new technology, secret codes are much more sophisticated than the Enigma, and with the threat of terrorists, code breaking is just as important as during World War II.